Assalamu alaikum warahmatullah. Today we'll learn about the method of separation of variable. Method of separation of variable for the solution. This is basically for the solution of partial differential equation. You must know that we have already discussed that in a previous lecture where we were solving the partial differential equation by using the direct integration method. In that case, we have discussed that if the differential operator are involving in only one term, then we can apply the direct integration method. But if the differential operator of either any of order, first order, second order, any of the order of the differential operator are appearing in any of the terms, then we'll have to use any another method. The first method that we have to discuss is the method of separation of variable here. This is same as that of the method of separation of variable in ordinary differential equation, but there are some steps that we have to follow. Let's suppose the step number 1. You know that the given equation is basically have z as your dependent variable. That is basically a function of x and y are the independent variables. In general, we can say z is a dependent variable, or maybe if you say u is your dependent variable, that is a function of x and y also. So basically हमें करना क्या है इसमें कि the first step we have to split or let's consider your dependent variable, that is basically of course a function of x and y, is equals to two new variables. Maybe let's suppose if we have first independent variable as x, we can say, let's suppose that the first variable or the function is x, variable x that depends on x. Similarly, that is multiplied by the variable y, that is a function of y. In this step, what we have done, basically the first function, let's suppose if u is your function that is depending on these two variables x and y, we split this multivariable function into two single valued function as x and y, maybe. Or for any other case, maybe if you have u as a function of x and t, can be splitted as x, a function of x only, into a function of t only. So basically, this will cause or change your partial differential equation to a single variable function, that is ordinary differential equation. So we'll have to solve that particular ordinary differential equation then. After this substitution, you just have to substitute the supposition, like for the simple case, we are just saying u is equals to capital X into t in given partial differential equation. We just have to substitute this partial differential equation and then separate the variables. This step is very much important. Somehow, if you don't separate the variable, then we cannot consider it to some another variable or any arbitrary constant. After the separation of variable, the step number 2 is you have to consider means let's suppose if you have an equation that have left hand side and right hand side, maybe in general I am saying the left hand side that is equals to right hand side. This is a general equation, and we have substituted u is equals to x into t and then separated the variables. After the separation of variables, I'm just saying you just have to consider this as equal to k, or maybe k square, or maybe minus k square, or any other suitable supposition. The word I use here as suitable supposition. Basically, For some cases, we can work with only supposing the partial differential equation with a separation of variable equal to k. We always can work, but somehow in some cases, like in wave equation, or maybe we can consider the wave equation only. In wave equation, we need the solution as a combination of trigonometric identities, sine or cosine. Since the wave equation is basically a combination of a sine wave or a cosine wave, so we may need any other supposition like minus k square, or we can say we will be in need of having a root of the ordinary differential equation, higher order ordinary differential equation, as a complex number. So we may consider as minus k square. We'll discuss it later in an example that where we can consider only k, and where we have to consider minus k square or k square or any other variable, or maybe in the last example or so, where will discuss it as if we suppose k, then what will be the solution? If we suppose k square, then what will be the solution? And if we suppose minus k square, what will be the solution? So with respect to the our given condition, we'll have to consider that particular solution. This is the second step. You have to consider it equal to k or k square or minus k square. That we'll discuss later in an example. What will be the suitable supposition for your particular case? But in step number 3, you can split the above equation into as left hand side is equals to k or k square or minus k square, or else, or right hand side is equals to k. So basically in that case, you have two differential equations now. The first, you have the partial differential equation, and you have splitted this partial differential equation into two differential equations. And of course, these differential equations will be ordinary differential equation. That is basically the working, that we have converted the partial differential equation into ordinary differential equations, two ordinary differential equation. Now, maybe in some cases, you have two first order ordinary differential equations that can be solved by any of the form that you have discussed in your previous lectures, where maybe these forms these equation will be of form variable separable, or homogeneous or non-homogeneous, or exact or non-exact, linear or Bernoulli, or any of the other case. And for the second order or higher order differential equation, ordinary differential equation, you have to evaluate the complementary function and particular integral as per the previous discussion. So basically, you have to solve these two equations for maybe the first equation is said to be, let's suppose if we solve the first equation, and this first equation is containing the variable, if this left hand side is basically containing the variable x, and this right hand side is let's suppose containing the variable t. For this case, we have two variables. So basically, what will happen from this, from the solution of this equation, maybe you can say the equation alpha, we can say this equation and beta. From equation alpha, you can evaluate the value of x. Similarly, from equation beta, you can evaluate the value of t. After the evaluation of x and t from equation alpha and beta, you can substitute this equation in the previous supposition. Whatever your supposition is, maybe if I say this is equation, maybe the general equation gamma. Let's suppose we just have to substitute x and t, that is evaluated separately from alpha and beta, in equation gamma to evaluate the general solution. Now this will be the general solution, and then if the conditions are given, initial or boundary value conditions are given, we'll have to evaluate the particular solution of the given partial differential equation. Let's start with some example. Let's suppose you have to use the method of separation of variable for the solution of the first order derivative of u with respect to x, that is equals to 2 times first order derivative of u with respect to t plus u, where you can say the variable u is a dependent variable that depends on x and t. Remember that the derivative is always be taken with respect to the independent variables. So if I just say this x, denominator dawa x, Dava, I'm saying again, as we have discussed in class, that we cannot treat this Dava as, but whatever the condition is, I'm currently saying this as Dava x, or the differential operator differential operator with respect to x. So basically, you have differentiate your u function with respect to x. Similarly, you have differentiate your u function with respect to t. So that is obvious that you have two independent variables. The first independent variable is x, and the second independent variable is t. So basically, we have u, that is a function of x and t, and this equation, maybe we can say this is equation number one from the starting. This equation number one is subjected to condition u x comma 0 is equals to 6 into exponent of minus 3x. So basically, yeah, this is the given condition of the to solve this differential equation. Now let's start the solution. What was the step number one? We have to consider this u, that is a function of x and t, into two functions, single valued function as x, and that is multiplied by t. In simple words, you can say u is basically equal to x into t. So let's suppose this is equation number two. We just have to substitute our supposition, or you can say substitute equation number two in equation number one. You will have the partial derivative with respect to x of x into t, that is equals to 2 times the partial derivative with respect to t of x into t plus x into t. We have just substituted the value of u as per our supposition. So if you partially differentiate x into t with respect to x, t can be considered as constant. So we can write it as t, the partial derivative of only x with respect to x. Since this is a partial differentiation, that's why we are taking t outside the differential operator. So similarly, the partial derivative with respect to t means this x is basically treated as constant. So we can take it outside the differential operator, that is with respect to t plus x into t. Now in this case, currently we have substituted and simplified some of the steps, simplified with respect to the partial differential operators. Now let's suppose after this simplification, we have to separate the variables. Now we have to separate the variables as before the separation of variable, we cannot consider it as equal to k or k square or minus k square, the step that was discussed. So basically we have to separate the variables. So I can just take x as a common from the right hand side. So you'll have two partial derivative of t with respect to t plus t remain on the right hand side, and t partial derivative of x with respect to x remain on the left hand side. Now you can separate the variable as capital X can be transferred to the left hand side and written as 1 divided by capital X d. Sorry, this will not be the differential operator d only. So basically, this is the partial derivative of x with respect to x, that is equals to this capital T can also be transferred to the right hand side. So you can write it as 2 divided by t, a partial derivative of t with respect to t, plus t divided by t can be written as equal to 1. So basically, you can see here, this is the form that is having separated variables. On the left hand side, you can see only x as a variable. On the right hand side, you can see only t as a variable. So basically, this is the variable separable form here. When you achieve this variable separable form, you have to take this variable separable form equal to k or k square or minus k square. So what we have discussed, right now we are just taking this equation or the variable separable form that is equals to k. In this second step, we have discussed that we have to take it, say that is equal to k. So after this step, in step number 3, we can say this left hand side 1 divided by x of the partial derivative with respect to x, that can be taken as equal to k, and the right hand side, that is 2 divided by t, a partial derivative of t with respect to t plus 1, that is equals to K. We have separated two equations, or we made this two equations from the above equation. Basically, this one is equation alpha, this one is equation beta. अच्छा, यहाँ अगर हम देखें तो इस इक्वेशन में when we are discussing that we have only x variable that is differentiated with respect to x only. So since we have only the one variable, you can write it as 1 divided by x of dx divided by d. Okay? Since this is only, we are dealing with only the one variable, one independent variable and one dependent variable. So this is basically ordinary differential equation. Similarly, for this case, we have only one independent variable and one dependent variable. So this is also a case of ordinary differential equation. So we can transfer, or we can write the representation DAVA into d dt plus 1, that is equals to k. So we can say this is equation alpha and this one is equation beta. The previous one can be cancelled. So basically we have to solve this equation alpha and equation beta. I hope के अब तक कोई ऐसी परेशानी होगी नहीं हमें. Now we just have to solve this equation alpha and equation beta to evaluate the value of x and capital X and capital T. So as we said, for the first equation, for solving equation alpha, we are just solving equation alpha right now. So equation alpha was 1 divided by x d capital X divided by d small x is equals to k. So we can see here, this is simple, a variable separable form of the first order ordinary differential equation. We can solve it as 1 divided by capital X dx is equals to k dx. So you can integrate on both sides. If we integrate on both sides, you will have ln capital X is equals to kx plus c1. Yeah, c1 as the constant of integration here. So you just have to evaluate capital X. So we are taking exponent on both sides, and exponent ln x is equals to exponent of kx plus c1. We can split this one as exponent of kx into exponent of c1, and exponent of ln are balancing each other. So capital X is equals to this one. We can also consider that exponent of c1 is equals to capital A. So you will have capital X that is equals to exponent of c1 as a into exponent of kx. This is the solution for capital X. We just have to substitute this capital X solution of capital X into the given in the previous equation that we have supposed as u is equals to x into t. Similarly, solving equation beta. The equation beta was 2 divided by capital T into dt divided by d small t plus 1. Sorry, this was plus 1. So is equals to k. So similarly, we are solving this equation as if we shift plus 1 on the right hand side, you will be having 2 divided by t d capital T divided by d small t, that is equals to k minus 1. So you can again shift 2 divided by t dt, that is equals to k minus 1 d small t. This is also a variable separable form. This was the variable separable form. That's why we have separated the variables of the first order differential equation, variable separable form. For solving the equation beta, this is also the variable separable form. So we can just we can solve it by just separating the variables here. So after the separation of the variables, we can integrate on the left hand side as well as on the right hand side. So you'll have 2 that is taken outside the integral, and 1 upon t. Integral of the 1 upon t can be written as ln capital T is equals to k minus 1 into t plus c2. Similarly, this 2 can be shifted to the right hand side in the first time, or maybe you can solve it as in a power of t. You can take it as a power of t, but as a simple form. You can say k minus 1 divided by 2 times t plus c2 divided by 2 आएगा. So this c2 divided by 2, c2 divided by 2 can be considered as any other variable. Maybe let's suppose if I say this is c3, let's say. So this will become k minus 1 divided by 2 times t plus c3 or ln t. So we just have to take exponent on both sides. मैं इसी step के अंदर लिख रहा हूँ. I'm just writing this in this same step as exponent of this one, the whole thing. So we can split as exponent or ln in this step. In the left hand side are balancing each other to evaluate the value of t as that is equals to exponent of k minus 1 divided by 2 into t into exponent of C3. Now you can see here exponent of C3 is equals to capital B. Let's say this is equal to capital B. So you'll have B into exponent of K minus 1 divided by 2 into T. This is the solution for capital T. What was our initial supposition? We have supposed as U that is equals to capital X into T. So U can be written as capital X, the solution of X, that is a into exponent of kx into t. The solution of t is b into exponent of k minus 1 divided by 2 into t. So you can write it as a into b is another some another constant. A into b can be written as c, let's suppose, into exponent of kx into exponent of k minus 1 divided by 2 into t. So this is basically the general solution of the given partial differential equation. This is the general solution. Now, we have to apply the initial value condition on this general solution here. Basically, we have to apply the given condition. The given condition was u of x comma 0 that is equals to 6 times exponent of minus 3x. So when you're applying this condition, you can see here the value of x will remain as x and the value of t is equals to 0. So we are just substituting the given condition in general solution. So after substitution of the general solution, you will have u that is x comma 0. This u is basically representing u x comma t. That is basically the general function. So u x comma 0 is equals to c times exponent of kx into exponent of k minus 1 divided by 2 into 0. The value of t is 0 here. So exponent of 0 is equals to 1. You will have only c into exponent of kx, and ux comma 0 is equals to 6 into exponent of minus 3x. So you can compare these two functions here. You can compare as the value of c is equals to 6 and the value of k is equals to minus 3. So basically, you have evaluated these two arbitrary constant, the value of c and the value of k by the given condition. You can apply the, you can evaluate or substitute this value of c and k in the general solution. So you will have the particular solution will be u that is equals to u that is a function of x and t that is equals to c. The value of c is evaluated as 6 exponent of k. The value of k substituted as minus 3x into exponent of minus 3 minus 1 divided by 2 into t. So you will have minus 4 divided by 2 here. So minus 4 divided by 2 is will become minus 2. 6 into exponent of minus 3x into exponent of minus 2t. U, x and t. So there is no arbitrary constant here. So this will be the particular solution of the given ordinary differential equation. So right now we have completed the first example. We have completed the solution of the first example of the partial differential equation through the method of separation of variables. In the next lecture, you'll learn about how can we solve the another example by using the method of separation of variable. Thank you. Allah Hafiz.